ABC Solar would like to take a moment to give a history of photovoltaic technology. Your system is the adoption of Einstein's vision. Yes, Albert Einstein won the Nobel Prize in Physics for his explanation of how light travels 93 million miles to get in a fistfight with the silicon atom, and how the photon knocks out the silica electron. The knocked out silica electron is harnessed to make electricity. Solar panels start in the ground as pure silica that can be mined. With one method, the silica is treated with various chemicals to become ready to be melted. The melting process will get the silica in a molten state that heads towards 1600 degrees Celsius. At this point, a crystal is drawn through the mixture and pulls up. This process starts the crystallization of the raw silica into a usable solar wafer. The wafer is sized to typically 60 millimeters and is on its way to becoming a solar cell. Simply put, a doping material is used to make one side of the silica wafer positive and the other negative. A hair-thin wire mesh is attached, and leads are placed to allow in-series connection of the cells. Now considered a solar cell, each just shy of half a volt DC. This magical number happens no matter how big the solar cell is. This phenomenon is not yet explainable by this writer, but I love thinking about it. The half-volt DC of the solar cell is the building block of a functioning solar panel. A 72 solar cell configuration is one of the most popular of the world's solar panel manufacturers. Half-volt DC times 72 equals 36 volts DC. This is the typical voltage range for a 72-cell solar panel. The 72 solar cells are connected to each other in series electrically. Lead-free solder and silver wire are used by our preferred manufacturers. The sheet of solar cells are encapsulated to back sheets and framed to safety glass with long-lasting anodized aluminum. A power connection device called a junction box is surgically attached to the back of the solar panel and glued in place. Two wires then extend from the junction box as positive and negative with quick connectors for ease of installation. Inverters. The SMA Sunny Central 250 kilowatt inverter shown here provides 250,000 watts continuous AC output power, and its improved CEC efficiency is up to 96%. The inverter does the magic of changing the solar DC-generated electricity to AC grid-capable power. The typical residential inverter will output at 240 volts open circuit. This is routed in two 120-volt circuits that are then configured to a safety disconnect switches and then backfed to the main panel in two 20-amp breakers. Inverters' input characteristics are key to understanding good and safe system design. The minimum and maximum DC input voltage, and the other is max amperage of each solar string. For the Sunny Boy SB7000, the input voltage range is 150 to 600 volts DC. The max amperage per string input is 18 at 240 volts. The SolarWorld 275-watt mono solar panel has an open circuit voltage of 39.4. If we just divide 600 by 39.4, we would get 15 solar panels in one string. But we have to take into consideration the lowest annual local temperature. The lower the temperature, the higher the voltage. In the case of Los Angeles weather, the calculation is 39.4 volts plus the multiplication of 39.4 volts times the lowest temperature minus 25 degrees C multiplied by the factor of the solar panels. Typically speaking, it adds about 4 volts, so the voltage of the solar panel in Los Angeles on the coldest day is 43.18 volts DC per panel. Now divide 600 by 43.18 and you get 13 panel max per string. A similar calculation is done on the highest temperature calculation. The higher the temperature, the lower the voltage. So this high temp calculation is important for smaller string sizes to make sure you have the minimum 150 volts needed for starting the inverter. Solar electric systems perform better in cooler climates compared to the desert. The desert does have the advantage of many more days of full sun. It's always a trade-off. Thank you. This is ABC Solar. Visit us at abcsolar.com.